Okay friends, in this class we will discuss how to derive Bohr's radius for hydrogen atom, that is represented by A naught, which is the same with 0.05 to 9 nanometer. So how this radius is calculated? Yes, using hydrogen atom model, Bohr was able to derive this number or able to measure the radius of hydrogen atom. As you know, hydrogen atom or a kind of atom has a circle model. Therefore, in the center there is proton, and also there is what? Electron. Here there is the radius. If this atom is hydrogen, its radius is 0.05 to 9 nanometer. Therefore, if you consider this atom, there is the interaction between the two particles. That interaction is coloumbic force of attraction, that represented by CF, which is the product of electron charge times the charge of proton times the total number of positive charge on the nucleus of the atom divided by 4 pi epsilon naught r squared. This is the same with just E times E. Just we use here E because charge of proton and electron are the same in magnitude but opposite in sign. Therefore, it becomes minus E squared Z divided by 4 pi epsilon naught r squared. Okay, just we can write the Coulombic force of attraction between the two particles in this way. Therefore, let us say this is equation 1. And also there is another kind of force that observed from this atom. That is centrifugal force. When this particle revolves around this nucleus, there will be centrifugal force. We can represent it using CG. It is what? Centrifugal force is mass of the particle times velocity square over radius. But here, epsilon means precious primitivity, R is the radius, and E is just charge, Z is positive charge, total positive charge on the atom. So, this one is equation 2. But both forces must be equal. That means minus E square Z divided by 4 pi epsilon naught R square is equals to M times V square over R. You can simplify this. Just these are cancel this R square. So we can write like this. Therefore, here we have another equation, which is equation 3. But Bohr says the momentum of a particle moving on a circular orbit is quantized. The momentum of a particle, the angular momentum of a particle, represented by this one, it is the product of its mass, velocity, and r. And it is quantized, n times h bar, where h bar is h Planck's constant divided by 2 pi. Therefore, mvr is equals to n times h divided by 2 pi. From this, v is equals to nh over 2 pi times m times r. So, we can insert this value on equation 3. Okay? Therefore, it becomes minus E squared Z divided by 4 pi epsilon naught R is the same with mass times V squared. That is n squared h squared divided by 2 pi. By the way, when we make it square, 4 pi squared, yes. Therefore, 4 pi square times m square times r square. Okay? Now we can simplify this equation. Here we have 4, it's cancelled by this 4, and pi is cancelled the square. And what we can have here r, this square can be cancelled because of the presence of r. And this must cancelled by this m square becomes m, only n. Therefore, the remaining thing here minus e square z divided by epsilon naught. This is the same with n square h square divided by pi m r. So, by rearranging this equation, r is equals to epsilon naught times n square times h square divided by e square z times pi m just. Yes? In this case, m is the mass of the particle, that's the mass of the electron. And h is Planck's constant. N, in case of hydrogen, it is 1. N here is equal to principal quantum number is here 1. Therefore, this one is constant. Free space permittivity, that's constant. N is 1, h is constant also. The magnitude of the charge of electron square, that is also constant. Z also, total positive charge of the nucleus of the atom. If you substitute all the given constant in this equation, you will get 0.0529 nanometer. So, this is how to calculate the radius of hydrogen atom using the two forces.